Hey guys, my name is Alex. I'm a student here at Johns Hopkins, and today we're going to get you guys ready to do the first lab. So for this lab, what you guys are going to have to do is to measure the distances between these 2 points on campus. The only problem is that you are also going to have to keep track of the error associated with this measurement. So in class you guys saw that when you do error measurements for addition, subtraction, multiplication, division, all that stuff, it's pretty simple. It's pretty straightforward. The only problem is that what happens if you have a function in there, like some sort of trig function? What do you do then? The problem is that for this assignment, there will be trigonometry involved, and you guys haven't really seen that yet. So I can't really do the math that's going to be on your lab assignment. That's for you guys to figure out on your own. But what I can do is a similar example, a really basic one, to show you guys how to attack these kinds of problems. So let's do a really basic example. Let's say you want to find the height of an object. Let's say you want to find the height of your girlfriend. Let's say you want to, I don't know, buy her a custom-made dress or something, and you don't want to ask her height. So let's say that's your girlfriend. She's really cute. And to measure her height using trigonometry, you just have to go out some distance, d, from your target, and then measure the angle from the ground to the top of her head, call the angle theta. And if she has some height, h, we can pretty easily say that h is going to be equal to d times the tangent of theta. And that problem is not too hard. That's like 8th grade. The only problem is that let's add error into this. So this means we're going to have our d plus or minus some delta d, and our theta plus or minus some delta theta. What this is going to result in is, no duh, some sort of h plus or minus delta h. So if we match the terms into this equation and take the upper bound of our errors, we can say that h plus delta h is going to be equal to, well, d plus delta d, the entire thing, times tangent of theta plus delta theta. So our mission in this is to get an expression, a concise expression for delta h. So what we want to do is to isolate this guy by moving this guy to the other side of the equation. It'll be really good if we can just get rid of that guy over there. Well, we see over here that h is going to be equal to d times the tangent of theta. But over here, we have tangent of theta plus delta theta. We have something that's combined inside the tangent term. What we want to do is to break up this term. So we want tangents of just theta and tangents of just delta theta, not something combined like this. Well, to get a formula for that, that's pretty simple. All you have to do is go ask Google, and he will tell you a really nice answer. If you want to do the derivation, it's really simple. I won't show it here in the interest of time, but all you have to do is you take sine over cosine, because tangent equals sine over cosine, correct? Well, we know from Algebra 2 and trig that sine of a plus b is going to be equal to this formula here, and cosine of a plus b is going to be equal to this formula here. The key to this entire derivation, though, is to divide both the numerator and the denominator of this term you get when you do sine over cosine by this term here. What happens is that if you divide by this term, you're going to be left with tangents on the top and 1 and tangents on the bottom, giving you this equation. This is the equation we want to use. So if we just simply substitute things in, where a is theta and b is delta theta, we say that tangent of theta plus delta theta is going to be equal to tangent of just theta plus the tangent of just delta theta over 1 minus the tangent of theta times the tangent of delta theta. Here, though, we can make a small approximation, because it just so happens, if you guys haven't seen this before, you're going to have to take my word on it, but it just so happens that if you have the graph of tangent of theta and you zoom in really close around the origin, you're going to find that for a while, tangent actually behaves quite linearly. So if we assume that delta theta is pretty small, which we should, tangent of a really small number is approximately equal to the really small number itself. So that means that tangent of delta theta is approximately equal to just delta theta. So we can just make that approximation and shove the guy in here. So we say this thing is approximately equal to tangent of theta plus delta theta over 1 minus delta theta times tangent of theta. The only thing I've done is substitute in delta thetas for these two guys here. That's all. Cool. So we now have an expression for tangent of theta plus delta theta in just tangents of theta and tangents of delta thetas. So now we can substitute the guy back in to the main equation, and then we can distribute these guys in. And what do we get? So if I'm going to move the h to the other side of the equation right away. So we're going to have that delta h is going to be equal to distributing these guys in to the numerator. We'll have d times tangent of theta plus d delta theta plus delta d tan theta plus delta d delta theta all over the bottom, which is going to be 1 minus delta theta tangent of theta. And then we move the h to the other side. So this will be over here minus h is equal to d tan theta. D times the tangent of theta. Now, what we can do is combine terms. We want to smash this guy into this large fraction here. So we're going to have to multiply this guy by this denominator to combine them in. So we see here that delta h is going to be equal to the same thing we have over here, d tan theta plus d delta theta plus delta d tan theta plus delta d delta theta minus d tangent of theta. All I'm doing is taking d tan theta and multiplying it by the bottom. So this will give you a minus d tangent of theta, and then a plus, because we have a minus and a minus, plus d tangent of theta, tangent squared of theta. Looks like I'm running out of room over here. I'll just squeeze him in over here. We don't really need this guy anymore. And this entire ugly thing all over the bottom. 1 minus delta theta times tangent of theta. All right. So we see here that we have a d tan theta and a negative d tan theta. They just neutralize each other. And then we can make one more approximation, namely the approximation that I haven't erased yet. So here we're assuming that our delta terms are pretty small. And in comparison to the other terms, if we have a really small number times a really small number, that's going to give you a really, really small number that in the grand scheme of things actually won't matter that much. And this is a trick that you guys might have to employ multiple times over the course of this lab, where if you have delta something times delta something else, you can approximate that thing to be so insignificant that you can basically drop it out of the equation. It's not equal to 0. And that's a subtlety that many people make, that they fail to make. Delta something times delta something else is not 0. It can just be dropped. So in here, we have a delta d times delta theta. So this thing can be dropped. And cool. we have here our final expression for delta H. So we have here that delta H is going to be equal to d delta theta plus delta d times tangent of theta plus d delta theta tangent squared theta all over the thing at the bottom, which is going to be 1 minus delta theta times tangent of theta. And cool, that's our answer. And it's so cool that it deserves a box. So, what should you guys retain from this? Well, 3 things really. One is that when you're doing these kinds of error measurements, first step is to always go back to the main equation and substitute in everything. Here, we just simply substitute in h, d, and theta, and that's all. And our trick is to try to make an expression for just the error term by getting rid of the other term over here. That's number 1. Number 2, if you have tangent of a really small number, that's going to be approximately equal to the really small number itself. And the last thing is that when you have a delta something times a delta something else, if that's not going to make that much of a difference in comparison to the other terms in the equation, if they're really small compared to everything else, you can basically drop it out of the equation. It's not going to matter much, right? Cool. So that's it for this time, and I'll see you guys later.